Hello everyone, this is Telecom Christopher. In today's episode, I shall focus on the centralized gateway and distributed gateway. And here the gateway, which means the VXLAN gateway. The gateway is the concept for the overlay. And here I focus on the VXLAN, Virtual Extended LAN. And then here as you can see the spine and leaf. You may feel strange. Then the spine and leaf shall fully mesh with each other, and then the spine and leaf shall be paired. For example, here is one spine and then there is another spine, one leaf for another leaf. Yes, you are correct. Because for easy understanding, I just draw one. So now I will explain in today's cloud-based or SDN-based data center, which is called the fabric, which means the spine and leaf fully meshed with each other. And then it is not only fully meshed because the fully mesh, which means high resilience, but also very large capacity. For example, the leaf and the spine, they will utilize the 100 giga Ethernet interfaces to connect with each other. And then on the other hand, the spine switches such as Huawei Cloud Engine 1 to 800 is very high performance, which is similar to traditional aggregation on the core switch. And then for the server switch, for the leaf here, the server switch is 4U high, which is top of rank and also called them TOR. So now let's back to the centralized gateway and distributed gateway. The centralized gateway, which means all the traffic will be detoured on spine. In other words, the spine is the bottleneck of the entire fabric. The routing table, the up table, if the size of the routing table and the out table is quite small, the entire fabric, the performance is low. So this is the drawback of the centralized gateway, and the spine here is suffer from great burden. If the spine failed, everything failed. So another evolved solution is called distributed gateway. All the traffic is detoured on the leaf here, which means the burden is scattered to the leaf. And what the spine do here? The spine is working as the forwarding plane, which is similar to the back plane of the router. High performance, focus on the performance only. Okay, let's move on to see the comparison of the centralized gateway and distributed gateway. Here for the layer 3 VXLAN gateway, the centralized gateway is on spine and distributed gateway is on leaf. And for the firewall deployment, there are two ways. The first one is the bypass, which means the firewall is connected to the spine or to a dedicated pair of leaf, which is called service leaf. Their bypass is not inline. Inline, which means direct connect with each other, and then the firewall will connect it to the outside. And the bypass, which means the firewall is on the side. The traffic will detour to the firewall and then back to the spine, back to the switch, and then go out. The bypass is a good design because if you use the inline, the scale of your fabric is not only restrained by your switch performance, but also by the firewall performance. The firewall tend to be the bottleneck for your entire switch because as we all know that the firewall is not good at layer 2 switch and layer 3 routing. What they do is do filtering to look up the layer 4 to layer 7 packet or layer 2, layer 4 to layer 7. Yeah, packet, use packet. Okay. Pancake. So it's better to use the bypass mode to deploy the firewall. And then for the control plane, For the VXLAN based data center, it must be the BGP EVPN. For example, we can say the Cisco ACI solution that they use the BGP EVPN also. And some other people said we may use the segment routing. Yeah, the segment routing, definitely, that is a good solution, because if you use the segment routing, the service will be collected with each other from the ingress to the egress via a seamless tunnel, which is similar to the seamless MPLS LSP, which is signaled by the BGP LU. Yeah, that is a good idea, but there is one thing to consider: the performance of the TOR. Whereas for the BGP LU scenario, the end-to-end seamlessly LSP is enabled on the PE. The PE router is very, very high performance. And how about the TOR here? It's just a switch. It's not a router. It's cheap. It is not that efficient. So for the data center, just from my point of view, we shall use the VXLAN. From the server leaf, start the VXLAN tunnel to the border leaf, do some decapsulation, and then from the border leaf to the PE or to the GC gateway, and then to connect with the peer DC gateway or the PE, which is on the provision of segment routing. This is what the vendors propose nowadays. And then for the forwarding plane, as you can see, centralized the gateway, the entire performance is restrained by SPI. Whereas for distributed gateway, the burden is scattered. It will be very high performance, but the OEM is complex. And then for the centralized gateway, because the OEM is definitely simple, only one spine, a pair of spine switch you will maintain, because all the traffic steering, the cross subnet, the cross tunnel traffic steering is on spine. For distributed gateway, is complex. Not only complex, but why we say the complex is not only because of the scattered layer 3 VXLAN gateway, but also from the SDN's point of view. They will find, for example, if you define a network on the OpenStack, a network is normally corresponding to a VRF here in the physical network, because in the SDN solution there are 3 layers: the management plane, which is the OS, SBS, like that, the control plane, which is definitely the OpenStack, and the SDN controller. SDN controller is integrated with the OpenStack via the RESTful API like this. And then the bottom layer is the physical switch. And then if you define a certain network on the OpenStack, what the SDN controller will do. SDN controller will randomly pick one VRF and to mapping with the subnetwork you define on the OpenStack. So it's very hard to tell where the VRF is and what the VRF name, what's the name of the VRF to correspond to map the subnet you define on the OpenStack. It's very hard to count. It's very hard for the OEM troubleshooting. For the scalability, as you can see, the centralized gateway solution is very, very high cost, because if the ports, if you want to expand it, you will add another pair of spine. For the distributed gateway, it's relatively low cost. You just add a pair of server leaf, that is okay. And to some extent, to some point, both solution, the centralized gateway and distributed gateway, they will add one more pair of spine, only if the interfaces, the physical interfaces on the SPI has been used. Okay, now let's move on to another topic, which is the Anycast Gateway. When we study the telecommunication or the data communication, we encounter several concepts such as the unicast, multicast, broadcast, and here another one is Anycast. What does the Anycast mean? So I will review one by one. For the unicast, one talk to the other. For the multicast, one talk to a group. For the broadcast, one talk to everyone. For the unicast, here's the story. One talk to a certain group, and he don't know how many person in that certain group, and then only one of this within that group reply to that request. This is called Anycast. So just from a point of view, the Anycast combine the feature of unicast and multicast. And traditionally, the common practice for the Anycast is the BGP plus Anycast Gateway to find the nearest DNS or do some anti-DDoS. It's quite easy to understand that. The first thing, the Anycast Gateway. Anycast Gateway is a group of servers share the same IP or the MAC address. And then the BGP which is based on the IGP, such as OSPF, always find the nearest one. So here in the DNS scenario, a client wants to access the DNS, whereas the DNS is located in different place. If all of the DNS in different place share the same IP and the MAC address, which is similar to the mechanism of VRP or something like that, they enable a request, they send a request, and one of them reply that request. And the client don't know which one. And for the BGP, it will help the client to find the nearest one, DNS, to do the replying work, which will ensure a better experience of network surfing. And in other words, if loads of people to make the same request, because this is a set, all of the DNS servers share the same IP and MAC address, the burden will be shared to each other. So this has some benefit to the anti-DDoS, because in the anti-DDoS story, all of the small traffic aggregated into the big traffic, and the big traffic to crack down a certain server or certain machine. If that certain machine has the Anycast Gateway, if the certain machine has Anycast Gateway deployed, then the traffic will be the burden of the traffic will be alleviated to different servers, which will help them to avoid the DDoS attack. And then here for the VXLAN Anycast Gateway, as you can see, all of the switches share the same IP and MAC. There are two ways from the Cisco's point of view. One is manually configure the MAC address, and then the other is called MAC ADS, which means, for example, the switch 1 will tell the switch 3, hey buddy, this MAC address I give you is the gateway MAC address for the virtual machine 1. When the virtual machine 1 jump to another subnet under SW3, the SW1 will not sense the change of the gateway. The VM1 will not sense the change of the gateway. The VM1 still feel that the gateway is the same, because the gateway share the same IP and MAC address. Okay, here is some key steps to configure the VXLAN Layer 3 gateway. As you can see, this one is a little bit hard to understand, but the key steps is the VPN instance and BGP EVPN instance configuration, and the routing exchange between the BGP EVPN instance and the VPN instance, and the BGP EVPN instance to BGP EVPN instance in another place. Okay, so let's see the configuration steps for the centralized gateway and distributed gateway. The first one is the IP reachability of underneath network. The same. And then to configure VLAN access point, which means to allow which traffic to be transmitted via the VXLAN tunnel. And then enable the BGP EVPN. You can select to disable that. If you do not want to use the BGP EVPN control plane, if you use that, you must configure the peering relation. And then configure the BGP EVPN and the VPN instance. For the centralized gateway, you just configure the BGP EVPN instance to propagate the certain route entry. And then configure the head and the peer list the same. Configure the layer 3 gateway on the spine. Here is on spine and leaf. And then configure the routing propagation among the BGP EVPN neighbors. And then let's take a look at the code. For the BGP EVPN and the VPN instance configuration, to understand that, we will see this diagram, this chart. There is a host root, which is the VM or the bare metal server. The VPN instance, which is the VRF, will know that routing entry. And then it propagates to the BGP EVPN instance on the VXLAN. And then the ingress side BGP EVPN instance will propagate this routing info to the other BGP EVPN instance. It will filter or exchange or something like that by the RD and the RT. And then here, the VPN instance will exchange the route and filter the route by using the RD and the RT also. And then he will load that, how to reach the destination. So there are two exchanging phases. The first one is exchange between the VPN instance and VRF. Here is the VPN instance is VRF to the BGP EVPN instance. And then another exchange and filtering is between the BGP EVPN instance. Okay. Here to make a comparison, VPN VRF, for example, HR department, R&D department. HR department talk to HR department here. So if they got all of the routing info here, combination of the HR, R&D, or the logistic department here, the HR department VRF definitely will filter the route entry they want to use. And then for the BGP VPN instance, because they collect with loads of BGP VPN instance, then it definitely has the RD and RT. They will see what kind of route entry I like. So let's take a look at the code. IP VPN instance VPN1, which is called the VPN instance. The name is VPN1. VXLAN VNI 5010, which is the identifier 5010 identifier of that VPN instance. And then here the RD and RT. And then for the EVPN instance is binding with the bridge domain and the VXLAN VNI. Yeah, it has the RD and RT. Okay, configured. And then let's take a look at the VXLAN layer 3 gateway. The VXLAN layer 3 gateway is similar to the traditional gateway. It must have some layer 3 gateway IP address to be configured. VPN instance is bind with the layer 3 VXLAN subinterface. We can remove the VXLAN here for easy understand. Layer 3 subinterface, because layer 2 the different VLAN want to connect with each other, they must have a layer 3 interface. And here, the layer 3 VXLAN interface is the same story. So as you can see here, it will be configured by the IP address VPN MAC address. This is the Anycast Giveaway. So it's the same. Because this Layer 3 VXLAN subinterface is called the VBDF. This one. We will apply one IP address. For example, not the code follow this device to interface VBDF10 IP address blah blah blah. Okay, the Anycast Gateway is enabled with the same MAC and IP for all hosts here, as you can see. This one is the VXLAN interface and the VXLAN layer 3 interface, and then to share the IP and MAC address. In different devices, device 2, 3, 4 is the same if you manually configure that, and then it will enable the Anycast Gateway. After that, if the layer 3 gateway is configured, and then they will exchange the IRB route between the BGP EVPN instance. As you can see here, advertise IRB, integrated routing and bridging packet with each other. So this one is, this slide will show you the configuration of the distributed gateway and the centralized gateway. But the most important thing is, don't forget, they have the VPN instance and the BGP EVPN instance. The BGP EVPN instance is working at the VXLAN. It's just for VXLAN only. And the VPN instance is traditional VRF. And then the traditional VRF will share, exchange, and filter the routing entry propagated from the BGP EVPN instance. And then there must be the same mechanism between the BGP EVPN instance. There are loads of route filtering, sharing, exchange among them. I think another thing is when all of the layer 3 VXLAN gateway configured, it will enable the type of the BGP EVPN packet to propagate or to share with each other. For example, the type 235. Okay, here is the end of today's episode. If you have any question, just leave me a message. Thank you.